anyone here from out of town? Where are you from?
Vancouver.
Vancouver. You're visiting Victoria?
Yep.
Anyone else from out of town? Are you all?
Yeah, we're out.
All right.
Saskatchewan.
Saskatchewan.
Right.
Regina?
Yeah.
Saskatchewan? I worked there for summer, so. I'm Ben. I'm the chair of the Friends of the Dominion Astrophysical Observatory, and I want to start off with a land acknowledgement. We at the center of the universe acknowledge that we live, work, and play, and learn on the unceded territory of the Sanchatan-speaking people, the Saanich Nation, who were given this responsibility to care for this land and all life by Hals, their creator. We recognize the very special relationship to Wase Saanich, the Little Saanich Mountain, that the Saanich people have had from time immemorial. And with that, I don't want to waste any more of James's time. Dr. James Francesco is probably the strongest supporter of public outreach currently at the National Research Council, and he is the director of the observatory and has been since 2018. James comes to us via, you're from Toronto, right? Yeah, Toronto, and then the University of Texas, Harvard-Smithsonian, and the University of California, Berkeley, so he's a bit of an underachiever. James has been here at DAO since 2002, and he became director in 2018. And so most of our speakers give us we ask them for a picture of what they're going to talk about. But because James is talking about pictures, we didn't bother to ask him, so it would be all a great surprise. So here he is.
Thank you, Ben. And again, you can all hear me okay? Okay, wonderful. I'm trying to get the microphone at the right level. Well, welcome to you all to the Dominion Astrophysical Observatory. As the director, I would like indeed to welcome you. It's a pleasure to be here tonight, and it's great to see so many people here interested in astronomy. So what I'm going to be talking tonight about is actually something new. I'm going to try something different. Rather than down on one particular subject, I thought I would try to convince you that astronomy is a very vibrant and exciting science, because it just strikes me that there seems to be news coming out almost every day about something interesting in astronomy, and I sometimes struggle to keep up with all the amazing things that are coming out. It really is a golden age of astronomy, but golden age sounds a little bit ancient, so I decided to call this the modern age of astronomy. And when I say modern, I mean really, I'm going to be talking about things that have only been news in the last 6 weeks. So it's very, very current stuff, and it's all very impressive and interesting. So I really do hope that you'll bear with me over the next half hour, and you'll be able to be impressed with some of the amazing things that we're learning about the universe even today. So again, we're here at the site of the Dominion Astrophysical Observatory, which has been and still is Canada's national observatory, and it is basically used by Canadians still. Every clear night, it is still looking out into the cosmos and doing really, really good science. It was established in 1918, so for the last 107 years, it's done a really great job of providing data to Canadian astronomers and allowing them to explore things of interest in the universe. It has a very long and storied history, but it is only one telescope of now many. And I'm going to be talking to you tonight about other telescopes, many of which Canada is a partner, and some of the exciting science that's coming out of those observatories. So I'd like to say that we're here in the shadow of the dome, but I work here beneath the dome at this place you drove by on the way up the hill. It's called the Hertzberg Astronomy and Astrophysics Research Center, and it's one of a dozen research centers of the National Research Council, which is Canada's federal research and technology organization. And so we are supported by the federal government in these endeavors, and we act as basically Canada's national laboratory for observational astronomy. What we do is we not only support and manage observatories like at the Dominion Astrophysical Observatory, but also the many offshore telescopes that we have partnerships with. And so we have people here, astronomers, who support Canadian users of the telescopes. We have also people who are building new instruments for those telescopes, as well as people who are managing all the data that comes off the telescopes. And so we really are a place that is providing access to these observatories and helping Canadians be some of the best astrophysicists in the world. Astronomy and astrophysics is nationally recognized as one of Canada's key strengths in science. In part, I like to think because we play such a major role in providing these opportunities for Canadian scientists. So we have manage a number of observatories. And again, what I'd like to describe to you tonight, though, is some of the most exciting things to come off those observatories in the last 6 weeks or so. So the first observatory I'd like to discuss is the Gemini North Telescope, which is on the summit of Mauna Kea in Hawaii. This is, here you go. This is the Gemini North Telescope. And like the name suggests, it's a twin, and there's a telescope just like it in the southern hemisphere as well. This one is located again in Hawaii, and it is 8 meters in diameter. And Canada has been involved in it for just over 25 years. This, by the way, next to it is the Canada-France-Hawaii telescope, which was one of the first of the telescopes to be on the summit of Mauna Kea. It is, this is 8 meters. This one here is about 3.6 meters, and it has been on the telescope since on the summit since about 1979 or so. But one of the most exciting things to come out of Gemini in the last 6 weeks has been imaging this source. This is a comet called Comet 3I Atlas. Have you heard about this? No? Well, it's actually a very interesting comet. So here is an observation of this comet. Here we go. And it seems like a bunch of different colors across the sky. And what this was a series of images taken by an instrument that we actually built here in Victoria called GMOS, and a number of different filters. So here we looked at in a red filter, a green filter, and a red filter as this source was moving across the sky. So comets are actually quite fast, and so this was being imaged successively in these different filters, and that's why we have these different colors. And then the people who took these observations very cleverly stacked them together to produce this image here. And this is one of the first nicest images of this comet. So what is a comet? A comet is a big ice ball, and as it nears the sun begins to heat its surface, and the gases melt off the surface of they're frozen as ice, and as they near the sun, they bubble off and produce these beautiful, lovely tails that we see in the night sky sometimes. But what's especially interesting about this comet, we see comets, maybe a good one comes by the Earth maybe once or twice a year. This one is especially interesting because it is actually not from our solar system. This one is actually an interstellar comet. It is a comet that it somehow was able to come towards the sun, and it is moving so fast, it's not going to stay in our solar system at all. It's moving at about 68 kilometers per second, which comes out to be about 245,000 kilometers per hour. So it is zipping right through the solar system, and it's fascinating because this comes from another star, and it has wandered the galaxy for perhaps billions of years until it just happened to encounter our sun, and it's just winding its way through the solar system, and perhaps for the very first time is being warmed by a star, so its outer layers are finally being boiled off. It's very fascinating to study such objects because stars are so far from us. It's very nice to have a piece of a star come towards us so we don't have to travel so far to study it. So by studying this, we can actually understand more about the composition of how another star formed that's very different from the sun. We can compare the composition of this comet to ones from our solar system to see the differences, for example. So this was one of the very nicest images on July 15th, but it was actually superseded by a lovely image made by this telescope, which I'm sure many of you are familiar with, the Hubble Space Telescope. Now this is actually another telescope we support down the hill. In fact, we have a complete archive of all of Hubble's data in our computers down the hill from 1990. And Hubble is still orbiting the Earth and continuing to take amazing data. And it actually made just this past, well, this was just released last week, but the observations were done on July the 21st of the comet here. So this comet is actually about 1 kilometer in size. It was first thought to be maybe 10 or 20 kilometers in size, but the Hubble observations made them to be actually much smaller. And yeah, and so it's starting to get its tail, and it's starting to get closer and closer to the sun. And here is a very nice animation showing where the comet will travel. It's actually going to pass quite close to Mars, but it has no chance of hitting the Earth at all. So the Earth is actually going to be on the other side of the sun when the comet actually passes closest to the sun here. And so we won't be at all in danger as it gets close to the sun. Nevertheless, it will still be observed quite intently, and many of Earth's observatories and satellite observatories are spending time looking at it. It's actually going to get very close to Jupiter as well. So this wayward comet is just passing through, and it's only the 3rd interstellar comet that has ever been detected. There was one detected back in 2017 and one in 2019. And we're now getting the capability of seeing these things, and we'll be able to see a lot more in the near future. But this one will actually pass close to the sun at the end of October, and then it will just wing its way out of the solar system, never to be seen again. So we have to tip our hat to it as it's passing through, but still a very fascinating discovery all the same. So the next observatory that I'd like to discuss is this one, the Atacama Large Millimetre Array. And it's very different from an optical telescope. This is actually a collection of 66 high-frequency radio telescopes that are situated on a high plateau in northern Chile. Each of these dishes is about 12 meters in diameter, though a few are smaller at 7 meters. But nevertheless, they are arranged here in a relatively compact configuration, and they observe at, as I said, high frequencies that optical telescopes can achieve. So while optical telescopes look at hot things like stars, these kinds of radio telescopes look at things like cold gas in between the stars, so we can understand where the stars, how the stars are formed and how planets are formed, and so forth. This one has been around for just a little bit over 10 years, and we have a group down the hill who support Canadian users for using this telescope as well. So I'm going to show you, we're going to zoom into one particular object that made the news just a couple of weeks ago, and happens to be in the constellation of Orion. Now, Orion is fairly well known. You can see its famous belt right here. And as we zoom in closer and closer, we see these dark regions where many stars are in the process of forming out of the vast clouds of gas and dust which populate some parts of the galaxy. And moving in closer and closer, we're getting towards one object which is called HOPS 315, which is called a protostar. So it's not even a star yet. It's just a young compact object that is still accreting gas from its surroundings. And actually it is in a very early state of its existence. And what's being shown here is showing some of the incredibly dynamic and turbulent activity that comes with a forming star. The star is actually buried in here, and you can't actually see it from ALMA observations. But what's shown here is the dramatic jets that are blasting off from the protostar itself. What's happening is that material is coming towards the star, but some of it, probably due to magnetic fields, is being whipped off and along the poles to make this beautiful jet here. And this is actually emission from a molecule called carbon monoxide in orange, and what's shown here in blue is emission from another molecule called silicon monoxide. So ALMA is very good at being able to pick out these so-called molecular tracers, but what's especially interesting about this object was that these observations and observations from another telescope allowed the scientists to find out that right where the star was forming, they were seeing the formation of the very first seeds that would eventually develop into planets. So interstellar gas and dust coagulate down towards the protostar, and they usually wind up in a disk, and very close to the protostar, it's warm enough that the carbon and the silicon are gas phase and they condense into a solid phase. And what they were able to find was a region where these dust particles were beginning to grow into eventually something that will form planets. And so there's a very nice animation that preceded this, that accompanied this, this story. And here we see some nice molecules that are then connecting to these dust grains in a cloud that is surrounding the star. And then here they are actually in the process of forming those seeds that will eventually make planets around this star. So the next observatory that we're going to talk about is the European Southern Observatory's Very Large Telescope. And this is a very pretty image. It actually doesn't have the moon crashing into it. It is 4 telescopes, each of which is about 8 meters in diameter. And this just happens to be taken during a lunar eclipse by someone who worked out when it would actually be placed behind the observatory. So this has been around for about as long as Gemini has been. And again, it's about a similar size. And this is also located in northern Chile, which is another great place to have large observatories. And it is basically Europe's premier observatory. And we're going to look into another forming star, and we're going to zoom into a different part of the galaxy. In this case, we're going to look not in Orion, but another constellation called Lupus, which is a little far south for us to see in Canada, but pretty good for people in the southern hemisphere, like those in Chile, who can see it very easily. So zooming in here, they looked at 2 stars called HD 135344 A and B. Now these are binary stars. You can see one is right next to the other. And when they zoomed into this one, using a special device that allowed them to block the star's light to such a detail that they were able to see the surrounding dust and gas in a disk, they found that it actually had this incredible spiral structure. I was quickly going through it and looking at a variety of instruments, one of which was from ALMA, but you can see here that the disk has this very interesting spiral structure, and there's a circle around this one because the scientists that worked on these data believe that they have actually found, for perhaps the first time, a protoplanet that is actually growing in the midst of one of these disks. So here, before I talked about how the seeds of planets were starting to form, this actually shows what is very likely to be a protoplanet that is still accreting matter from its surrounding disk, and in fact is probably responsible for creating the spiral pattern in the disk that we see around here as well. And here's another image of it, where again the light from the star has been very carefully blocked, yeah, this appears to be a protoplanet maybe 2 times the mass of Jupiter. And this was only discovered just a couple of weeks ago. In an interesting counterpoint, I said that this was a binary star. It's only maybe about 1 million or 2 years old, which sounds like a lot of time, but for a star that's nothing. Yeah, its star that is actually not so far away was actually also looked at in the same way, and it actually has a young planet around it. So here this is the position of the star, and here is actually this planet, which is orbiting the star in a very elliptical orbit. This one is actually about 10 times the mass of Jupiter, as has been estimated. And this has been observed over the last several years. And you can see it slowly beginning to wind its way around the star. And it's actually quite interesting to have this observation because, as I said, these 2 stars are young and they're side by side, yet one has a disk and one does not. It has a planet already. Now, I said that the other one has a planet that's forming, but it's still fascinating to see how the universe makes planets at different rates depending on maybe the mass of the star that's involved as well. This star here is a little bit more massive than its neighbor, and so perhaps it's able to form planets more quickly as a result. A very fascinating result. So next, many of you have probably heard of this telescope, the James Webb Space Telescope, because it is probably the most important and newsworthy telescope worldwide right now. So the James Webb Space Telescope is 6.5 meters in diameter, It's located in space. This is an artist's conception because no one can go to where it's located. But since its launch back in the end of 2021, it has been just incredible in the amazing pictures and insight it has been able to produce. Because no one has ever put a telescope of this magnitude in space before. It observes at infrared wavelengths, which are longer wavelengths than our eye can see, but is able to pierce some of the dust that surrounds these dark regions where stars form, and is able to obtain very highly detailed images of those regions very well. And back in about a month ago, it was the 3rd anniversary of Webb producing images to the public, and to celebrate, NASA released this beautiful image of a star-forming region called NGC 6334, also known as the Cat's Paw Nebula. Now, why is that? Well, these sort of look like toe beans, you know? But anyway, each of these, this shows a region in the galaxy about 5,000 light years away, which is a place where many stars are in the process of forming out of these vast clouds of gas and dust. And just, it's incredible to see the amount of detail that Webb is able to recover just from being able to look at a location for just a little bit of time. What's shown here is, of course, a field of stars, but you can see the dust. And this dusty region is the locations where new generations of stars are condensing out of that gas. It happens in very dark places, some that are so dark that even Webb can't get through the veil of that blocks the dust, blocks the eye from seeing the young stars within it. But these lovely blue regions are actually places in the cloud that young stars have blown out through their light and their winds. They're able to excavate these cavities around the gas and push them into these surroundings here that may actually trigger the formation of new stars in the cloud. And there's this lovely animation that NASA produced, which allows us to zoom in on the Cat's Paw Nebula a little better. And we'll just go through this quickly. So, okay, the stars moving is sort of artistic license, just to denote that we're actually getting closer. But as we look more closely at these toe beans in the Cat's Paw Nebula, you can just see the amazing amounts of structure that's shown as these stars like this are able to blow out these cavities. And over here, you can see this little knot that's facing the star, and this little dark spot is probably going to collapse and form another star in the relatively near future. And again, this shows how stars influence their environments and produce even more generations of stars as they themselves form. And then moving along from that lower left excavated cavity, we're moving up through, and you can just see the incredible amounts of detail revealed by Webb. And up here, we're going to zoom into this upper region, which really gives us a nice view of it's almost in 3 dimensions about how this one star here appears to have blown out this big cavity here. That is, again, a bubble of hot gas that is pushing the surrounding gas and dust. And this is actually called the Opera House because it sort of looks like the Sydney Opera House from one perspective. Okay, so next we're going to look at this observatory. So this is a very, very new observatory. This one's called the Vera C. Rubin Observatory, and it was established, well, this year. Here's a picture of it. It is also located in Chile. Now, it is 8 meters in diameter as well. And now you're probably thinking, well, what does this telescope bring to the table that those other 8-meter telescopes that I've been talking about don't already do? Well, Rubin has been designed actually with a massive camera that will allow it to take a picture of the entire sky every 3 nights. And it will do that successively for 10 years of time. And by doing that, it will be able to see the very slight changes in star brightness and the motions of some objects in the sky. And there's enormous amounts of science that we'll be able to do with that kind of temporal coverage that previously astronomers have never really had access to this scale. Here's a picture of that camera. And again, to scale, this is some fellow here. And he's being very careful. He's in a good suit, so he doesn't get any dust on the camera's surface. It is basically 3,200 megapixels, or about the same size as about 260 cell phone cameras glued together. And it's in this cylinder here. And so at the beginning, or the end of June, we got the very first image from Rubin, and here it is here. And this is an absolutely gorgeous image of the Trifid Nebula and this large nebula here called the Lagoon Nebula. And this is an optical image. It's in the same wavelengths that we see with our eyes. And so it looks a little bit different than the Cat's Paw Nebula, which is in the infrared. One of the main differences is that we see these very red regions here. And these are the result of the very hot stars in this particular region forming stars that are stripping the electrons off of the surrounding hydrogen gas. And some of those electrons recombine with the hydrogen nuclei, and as they recombine, they glow at certain colors, like this very distinctive red color. And so this is a signpost, if you will, of high mass stars that are forming in the galaxy. And this particular region just happens to be towards the center of our galaxy. These are located at about 5,000 to 5,200 light years distance. And just all of this yellow that you see here are stars that you can barely discern from where you're sitting. But it's very difficult to show the true extent of Rubin data because it's very hard to get an image with enough resolution on this particular screen. You would need a screen that's several stories tall to get the image in exactly the kind of scale that you'd be able to see. But thankfully, the observatory released its own video, which shows some very nice zoom-ins of some of the images. So here's the Trifid Nebula, and you can see here how the stars resolve into these beautiful, and this just shows the scale, just an enormous image. The Webb image that is just a small little segment of this. Again, Rubin's camera is so big, it can take images like this of incredible detail, given its size, in a way that, again, we've never really had the ability to do before. And just going through this image, we can just see again how incredibly beautiful and awe-inspiring some of these galactic vistas are. Again, you see the inky black dark regions, which are the places where the next generation of stars are likely to form. And maybe here you can see how they've been pushed together. But yeah, so that was a very exciting first image from Rubin. But they actually gave us two exciting images. And this was the second one, which is a beautiful image of a cluster of galaxies in the constellation of Virgo. Now this just shows, these are objects that are well beyond our own galaxy, and they are many, many millions of light years away. And here you can see spiral galaxies that are very much like our own Milky Way, just next to each other, though they're probably at some distance. Up here, we see three galaxies that appear to be interacting and are stripping their outer stars from each other. This yellow is actually stars that are being torn out of one galaxy and spread towards other galaxies. And just an incredible variety. Probably each of the dots in this image, well, maybe not these, are galaxies that we're able to see in this field. This image, though, is only 2% of the size of a Rubin footprint on the sky. And to show exactly what they saw, they released this animation. And exploring this galaxy cluster image in a little bit greater detail is quite impressive. Again, we see all of these galaxies, which are collections of stars, each is a billion or maybe hundreds of billions of stars each. And each one of these is able to be resolved to incredible detail with this new camera. And here we are zooming into the region that we looked at before. Really an incredible thing to see, and it's been such a long time coming, this observatory. It was, and this shows, again, the footprints that Webb's camera is able to show, or able to do in one location. So this is going to start with this all-sky survey probably at the beginning of next year. And as I said, it will continue operating every clear night for the next 10 years and take images of things that change. And just to show you some of the things it was able to do practically effortlessly, there's this video that shows how it was able to see many asteroids in its field. So here is a star, here's a galaxy, and here's a previously undetected asteroid. We see it by observing it successively. It's moving against the far distant background stars and galaxies. And you can see how in this one image, this is the galaxy image I just showed you, they saw many, many asteroids. Many, many asteroids. It's quite impressive to see. But this one, this is really impressive. They found about 1,000 on the first night. Then they found about 1,350 then the second night. And then by the end of the 7th night, they found about 2,100 brand new asteroids, or newly discovered asteroids. And where are they all located? Well, they're only looking in one direction. And this just shows from the Earth, they were able to look out into the asteroid belt beyond Mars in this one location. So it's expected that Rubin is going to revolutionize our understanding of the asteroid belt because it will take a census of such asteroids very, very easily. Okay, so our very last image is one by this observatory, which is a bit of a strange one because it's actually several observatories that are bound together. Now, I showed you that ALMA is a series of 66 radio antennas that are tied together, but they're actually spread out only over about 15 kilometers or so maximum. But the reason you do that is because when you take a telescope like ALMA and move its antennas that far apart, you can synthesize the response of a telescope that is as big as the distance between the farthest telescopes away. So basically, in ALMA's case, you can see details that a 15-kilometer wide telescope would see. It's actually a pretty cool technique, and you can expand that by having telescopes further and further apart. And so around the globe, there are many radio telescopes that can be tied together to produce a telescope that is as large as the Earth. We can have telescopes here in North America, ones in Europe, ones in Korea, and ones in Africa, ones here in the Canary Islands, and all of these can record data, and the data can be combined to produce an Earth-sized telescope. But then you could launch a satellite and have it be an antenna as well, and then you, like this one here called Spectre-R, and it also can be added to this network of telescopes, and you can synthesize an observatory, a telescope that is 5 times the diameter of the Earth, allowing you to see things that, again, are extremely difficult to see otherwise. So they took this, a team of scientists took this capability, and they pointed it at this object called OJ287. OJ is for Ohio. It's not that O.J. Simpson was an amateur astronomer who discovered it, but nevertheless, it's this sort of innocuous-looking object here, which has puzzled people for about 100 years because it has shown variability both in optical and in radio wavelengths. So what is this object? So they looked at this object with this network of radio telescopes, and they found this incredible array of, well, blobs, okay? Now, this may not look very impressive to you, but what this is a jet emanating from a supermassive black hole in the center of this galaxy, which is about 4 or 5 billion light years away from the Earth. And they needed to have this kind of high detail to be able to see that this jet is actually kind of changing position over time. The black hole is probably located right here, and it has this jet of hot gas that comes in and is blown out, again like that young star, but at speeds that are very close to the speed of light, which is the fastest speed there is. It's an incredible thing to happen. But why is it bending like that? And so this team thinks that what's happening is that the disk around the black hole is precessing. It's spinning like a top, and it's sometimes orbiting. It's spinning and it's rotating around that axis of rotation. And what's perturbing it is actually quite fascinating. So what it is that this black hole is humongous. It is 18 billion times the mass of the sun. Every galaxy has a black hole of this, a supermassive black hole in its center. The Milky Way has one that's only 4 million. This is 10,000 times larger than that. And what they find is that this black hole is actually being orbited by another black hole. This one is actually only 150 million times the mass of the sun. And every 12 years, it seems to pass through the disk of the bigger black hole. And when it does, it emits an enormous pulse, a very bright pulse that is about 1 trillion times the luminosity of our sun, which is equivalent basically to the entire luminosity of the Milky Way galaxy. So it's able to do this in this crazy spirograph-like orbit because of the complicated physics, and it's able to produce these pulses, and they're able to explain these pulses as a result of this wild dance that's occurring in this system. Eventually, that 150 million solar mass black hole will merge with the 18 billion one, solar mass one, and basically produce a bigger one. But that will be, this will happen sometime in the next 10,000 years or so, but it will be a very spectacular boom when it occurs. So that basically wraps up my very quick and, hopefully not exhausting survey of recent astronomy news. As I said before, astronomy is something that is very vibrant and dynamic. There's always new stuff coming out, and if you're very interested, this is a list of some very nice news resources. These are websites that I look at every day. Phys.org, Universe Today, which is actually here on Vancouver Island, Space.com, and this one here, which is called the Astronomy Picture of the Day. These are incredibly good resources for finding out what's new and exciting in astronomy. And I can barely keep up with all the amazing things that are going on. And if you're interested in receiving a daily email about astronomy from yours truly, let me know. I'll add you to my list. With that, I thank you for coming. Have a great evening. So I'd be happy to answer any questions you might have about the presentation or otherwise. Oh, yeah, please go ahead.